Hey, welcome back everyone. You're watching Centerline Designs. My name's Cole if you're new to the channel, and we're back on the Snowcat project again. In this video, we're gonna be focusing on making the pump shaft. What that is it's gonna be connecting to the flywheel on our Volkswagen Turbo diesel, and then coupling up to our double piston pump setup that's gonna be powering the tracks. So in order to make this, we're gonna be using our CNC plasma table, and then we're gonna be doing some more machining on our 1942 Southbend lathe. If you think that interests you, just sit back, relax, and enjoy the video. Before we pull this off, actually, I need to get a bit of a distance measurement here. All right, well, we got the bell housing assembly and the pump support plate all freed up. I'm gonna go ahead and wipe this stuff down with acetone, and then I'm gonna coat it in like a bed liner. It's a really heavy duty coating. It etches in really nicely on the material. I think it will look good. If you're interested in seeing how all this stuff was built, I have a whole playlist, I think with 27 videos now of basically every aspect of this build. I've made a point to video even some of the smaller aspects because I don't know, I just figure I'll show you guys everything. With that shipping container project almost wrapped up, I can't wait to get some of the non-essential shop things out of here, like the quad and all the other storage items. This is gonna be going right to a shop, nothing else. Okay, well, after a little bit of figuring here, I think I have it worked out. This may be hard for you to see, but this consists of a 7 1/4 inch piece of 3/8 plate that's gonna have a shoulder machined into it that matches the shoulder on this flywheel. There will then be drilled through holes through here that tap into the flywheel, and that's how it will all get connected. There will also be a bore in this plate that accepts this shaft. We're gonna press it in on an interference fit and weld it, and when all that's together, then we'll go ahead and machine the shaft down to the same shaft size as our pump, and then put a keyway in it, and then we'll just make a little coupler to connect the pump to this shaft. So we're gonna start by boring that hole in there, pressing this in, welding it, then we'll go ahead and take care of all of that machining. So the first steps are gonna be get this piece of scrap 3/8 plate. We'll get a 7 1/2 inch circle cut out of it because I'm going to rough it out larger, and that will be one of the final items we machine at the end. So yeah, let's get over to the CNC table and we'll get this started. Well, there we go. That thing sure is handy, boy. I would have struggled to rough out what I needed that easily. So I'm just gonna go ahead, cut the edges down a little bit with the grinder, deburr it, and then chuck this up in the lathe, and let's get the center bore to diameter. Well, there you have it. That went together pretty well. We got to get it all welded up. I'm very curious to see how true it is. But yeah, there you go. That worked really good. I'm guessing the fit was a little looser than I planned, but that's okay. It still went in. Alrighty, we got that within about a thou, which is gonna be plenty good for what we're doing here. There we go, we got that pretty close now, so I'm gonna go ahead and weld this. All right, well, we do have a nice shaft here. It's square to the plate, but you ever make a plan and then just forget to follow it? Yeah, I was too eager to get boring this hole out. I didn't pay attention to just simple things. It wasn't a big deal, but you know, I didn't surface prep for my welds prior, so I had to get in there with a die grinder and clean that out. And I had to swap back and forth from my 3-jaw to my 4-jaw, whereas if I would have thought about it or just followed my plan, I would have been able to do the work on the 3-jaw, go to the 4, and not have to flip back and forth. Oh well, I'm not a professional machinist by any means. I'm just self-taught. I learn by playing, and yeah, it is what it is. Not a big deal, but we got this. It's pretty true. I mean, close enough. Like I say, I'm gonna turn the outer diameter of the shaft down once it's fully welded, and then I know 100% it'll be square to the back, which is what I want. So let's go ahead. We're gonna TIG weld this in place, put a nice big fillet weld on the other side, and then we'll radius that down, and yeah, we should be good to go. So. Well, it's definitely welded. I'm gonna let this cool down. It's really, really hot, so we need to let it come back down to its normal size, and then we'll get to machining some of those critical dimensions. So we'll see you in 2 seconds. Okay, well, I've gone ahead and trued this up based on this inside, and not too bad. Okay, well, you can see there really is not much run out on this, which is perfect. So we're gonna go ahead, put a center in. We're gonna machine this down, machine the end to the diameter of the pump shaft, and then when that's all done, we can go ahead and flip it, and we'll hold on to the shaft, and then we'll face the backside and the OD of this plate. So. All right, well that took a while, but that's within a thou, which is good for the girls I go out with. My large set of calipers don't appear to be working. They keep giving me really, really bad readings. So in order to set my DRO to the diameter, the minor diameter we're going to, I need to get close to it so that I can use my 6-inch calipers and then put the measurement in. So I'm just gonna roughly mark 3/4 of an inch in, and then we'll go from there. I'm doing it a little goofy. Well, I'd love to say that went flawlessly, but it didn't. The camera died and I took it down to the measurement I thought, which turns out was just a couple thou too loose, and it had just an ever so slight amount of play when I put the shoulder in, and that's not what we want. We need it like bang on a really tight fit to ensure that everything is concentric. So I went ahead and I just added some material back. I TIG welded a bead all the way around that shoulder and then machined it down just about 2 thou larger, and it's just a perfect snug fit. There is like no play there. So that should be really good.
Well, I hear YouTube videos getting filmed right now.
You do.
Sweet. Hi.
All right, I checked that with the dial indicator, and I have about a 1/2 thou of play in this shoulder. So I think that's gonna be perfectly fine for what we're doing. I think something I'll be able to do after we drill and tap the holes into the flywheel to hold this down is I should be able to put this whole flywheel in the lathe and check that everything is in line and concentric. And if it isn't, then I guess we're gonna have to go and redo it. Alrighty, let's get to marking some holes.
I really need something else to cut this wood. Because my arm hurts very bad. Dad, when
You know I am videoing, right?
yeah, I know. I want to ask, there's a thing after your watching the video.
Okay, I got everything clamped down here and I'm ready to drill the holes through the shaft and the flywheel together. They may not be perfect spacing, so I'm gonna go ahead and stamp a mark on here and here, just like an alignment mark. So then it won't really matter if the bolt pattern isn't perfect. So. Well, I think that is basically done. I don't have any grade 8 5/16 right now, but I'll pick some up. It's pretty good. Got my wife out cutting the lawn and everything. All right, now for the true test. Let's see when the flywheel is dialed in, if this is dialed in. Because if it's not, then we got to go back to the drawing board. Oh, we're way out of round. Okay. slow. Just do it up. Okay, we're within about a half a thou there, so let's see how we are on the shaft. I mean, it looks pretty straight. All right, well, we had about 5 thou, 7 thou total run out there. I don't think that's terrible. The coupler's gonna have a little play. I think I'm gonna leave it there. If I had to, I could maybe take a very small cut on here and that would true it up. In hindsight, I should have finished my cut, my final passes with it together like this. I wasn't really thinking I could do that, but really works perfectly. So yeah, gotta take this apart and get a keyway milled in it now. So we got everything set up here. I'm gonna kind of make life easier by doing it the hard way, if that makes any sense. I'm gonna go ahead and use a 1/4 inch end mill and put a keyway in because I have 1/4 inch key stock. I don't have any 6mm key stock or have a 6mm end mill. So I'm just gonna go ahead and put 2 keyways in the coupler, a 6 on one side and a 1/4 on the other, and that kind of solves my problem. So, all right, let's get this milled. All right, well, we just checked off another box of a long list of things to get done, so there we go. We got it done. I'd love to show you a lot more, but you're just gonna have to stay tuned for another episode. So thank you so much for watching. I really do appreciate all the support, and we'll see you later. Thanks.